Welcome, everybody. We're going to be working on the Chapter 2 exercises this evening. You can see them detailed on the screen here. I do have my ebook up so I can grab the program description. And then what I'm going to do is I'm going to actually copy that description into my IDE, by the way, so I don't have to flip back and forth between the two. So I'm just going to throw the first program right into the top portion of my document here as a comment, but there it is. That way I don't have to flip around and look. All right, so our challenge is to write a program that displays the dimensions of a letter-sized 8.5 by 11-inch piece of paper in millimeters. There are 25.4 millimeters per inch. Use constants and comments in your program. All right, so let's talk about the last thing first, right? We're already using a couple of comments here. So like whenever we create a spider program, you always get this weird thing up at the top. And by the way, one way to create a comment in Python is very simply to put a pound sign at the beginning of the line, meaning anything that follows that will become non-executing. It won't execute code. So really, it also tells you this is irrelevant. We don't even need it. So you don't have to have that there, by the way. Another way to do comments is to use this weird approach with these like triple quotation marks. Not a huge fan because I'm not comfortable with it. This is kind of a new school thing, but they throw it in. You notice how it automatically drops in your author info, the date created. I can see how that could be useful, right? And then what the kind of the convention in Python is if you're really writing a true piece of software that you're sharing with others, you would give a little prologue of what this is about and what it does. So if people are looking at your code, you would know. Now I have the assignment description here. That's not too bad, right? So I'm going to leave that there, right, for now. But if I did want to create another comment anywhere in my code, I can just very simply throw in a pound sign and then just start typing stuff. And then it's not going to do anything, but here's information for me, right? That's a comment. If I was to do something like a print command, and I'm going to do a blank one, and then at the end of the line, I do a pound sign and type in some stuff. That's also a comment. So I can put a comment right after a snippet of code. You know, in the old days, I would use this one a lot as like, for example, I might put in something like, this is where I left off. Remember, whatever. But it would be just a tip for myself. All right. Those are just examples. The more practical thing that I often do with these is sometimes I'll write a piece of code and it doesn't work. And instead of deleting it, I leave it there, but put a comment mark in front of it so I can always refer back to it. Like sometimes I'll also write a piece of code that works, but not exactly how I want. So I write another piece of code that works and not exactly how I want. And I keep all of them. And then when I decide on the one that I want, I delete the others, right? Or I leave them. Doesn't really matter. Sometimes I leave my footsteps there. Often what I do when I'm doing classes is I will do something much more interesting, which is I'll correlate like stuff we're reading in the book or concepts that I've talked about with the code that we're about to do. So for example, I'm going to label this section my inputs. And remember that whole concept of inputs, processing, output? Remember that scenario? Well, here I'm labeling it for you. The first part of my program is going to be my inputs. And we're told up here to use constants. So first, we're talking about constants, and constants are kind of a weird form of variables. So this is kind of a little bit convoluted and a little bit off topic of the actual exercise, but it's necessary to get to the point where you're understanding the exercise. So I'm doing a little precursor, basically. It's kind of like the prequel before you see the sequel, I guess. But generally speaking, whenever we're working in Python and we want to declare a variable, I can name a variable anything I want. So here's one of my standard snarky ones. Whatever equals I don't know, 5. You know? Once again, whenever we declare a variable, this is just an example, right? So you don't have to type this in. I'd rather you just pay attention now, but you could, code along if you wish. Whatever is the name of the variable, the equal sign, remember, is not for math. It's the assignment statement. And what I'm doing is I'm assigning the value of 5, the thing on the right side of the equal sign, I'm assigning it to the variable on the left. So right now, this variable holds the number 5. And it is a number in this circumstance. And to prove that it's holding that number, I'm going to print whatever. So what that will do is it'll take that variable, that whatever is stored inside of it, and it's going to output it to the console. And there you go, number 5. Right. The other thing that we learned also is that Python is also not strongly typed, right? So in other words, if I wanted to change that number 5 to the word 5 inside of double quotes, and then print whatever again, I want you to indeed see that it will change from a numeric format to a string, and it doesn't care. Welcome to Python, folks. So if anybody who's coded before, this is weird. Perfectly normal in Python. Not that we use it this way, but it works that way. All right. So this is basically how a variable works. And you know what? I'm deleting this, by the way. But there's also another construct that we learn in programming. And once again, for those of you that have done traditional programming, you learn that there's this other concept called a constant. And basically, I'm just going to make a comment here. Constants are like variables, but they don't change. In other words, the value is not going to change if I make something a constant. And there's a naming convention for constants too. And that is, if I have something, like if I was going to put that value into whatever, and I want it to be considered a constant, I would type it in all uppercase. And if it had logical words within its naming, I would separate those logical words with underscored. So I would say whatever num equals 5. And the reason that programmers do this, right? And by the way, this is a convention, not a rule, that constants are named uppercase with underscores separating logical words, because that way, when I look at my code, I can instantly go, oh, that's a constant. That's why we do it. And this is true in other languages as well. So if you compare to Java or C#, like two other major languages that we teach here, students often think, well, I have to name my constants uppercase. Well, no, you actually don't, even in those other languages. Here's the kicker in Python, though. Constants in Python aren't really constant. If I was in Java, for example, if I declared a constant, I could not actually change its value, even if I tried. In Python, we do this symbolically. So there's a couple of pieces of information, by the way, that they're giving us up here. There's actually 3 pieces of information that are hard-coded givens and aren't going to change, right? That is the length and the width of the piece of paper in inches, and the conversion from inches to millimeters. Those are just givens. Whenever you have a piece of information in a computer program that's a given, you usually make it a constant, right? Because it's never going to change. So for an example, if I was to create a constant that indicated and I'm going to turn on my caps lock here, and hopefully that doesn't burn me later, length of paper, or actually this, I'm thinking width here, so I apologize. Width of paper in inches. And notice how excessively verbose the variable name is. So old school programming, whenever we would name something, we'd always try to be as short as possible with it because we didn't want to type that much mostly. And then we'd come back later and look at our code and goes, what the hell is that variable? I don't even remember. And so the modern convention has become, no, say exactly what it is. Right. And so what's the width of paper in inches? Well, it's 8.5. 8.5 is the width. All right. Well, that's a whole lot like the length. So notice I'm being clever and copy pasting here. And I'm going to just change the first word to, oops, and there's the burn. Length of paper in inches is 11.
Your mic's breaking up.
Is it?
Yeah.
Yeah, so
That bad. I thought it was my mic for a second.
yeah, I thought it was
Yeah, yeah, it's bad.
but it is like crispy.
Crispy. Okay. What we'll do is maybe during the break, which we'll take soon, I'm assuming that I'm hitting some processing limits here. So let me just check my task manager. Let's see where I'm at. The speed's good. Let me try a real quick little trick here. So, all right. So the other little tidbit I'm going to throw in here, and this is a little bit strange, is because we're going to do mathematical conversions, the length of paper in inches is 11. But because we're going to be multiplying against other numbers that had decimal points, I'm including 0.0 to make sure that I have decimal accuracy in my calculations. So another thing you're going to learn is that when you're coercing math inside of Python, that whether you include decimal places or not can change the type of answer you get. And part of this is really an accuracy thing. And the other portion of it is what happens in computer processing, where numbers are dynamically changed from floating point values to integers. And then all of it in the computer memory is actually being converted to binary to do all the mathematics. So we have this error that happens with certain numbers because of that conversion from the base 2 number system to the base 10 number system. I know that's kind of heady kind of stuff, but that's what's going on in the background. Right. The other piece of given information is the number of millimeters per inch. All right. So I'm gonna go millimeters. There's 2 L's in there, right? Millimeters underscore per inch, being very verbose, and that number is 25.4. Right. Believe it or not, we're going to take a break right now because I'm looking at the clock. We're a solid hour in, so I want to like kind of take that break. We'll come back and resume, and we should be able to get through all these exercises no problem. So I'll see you guys in 5, but I am pausing. All right, we are back from break, and we're going to finish off this program here. So we have our inputs, and okay, these don't feel like inputs because we're not asking a user for them, but we will get to that point. Right now, this is just numerical information that comes in. We're being asked a question, so we're considering it an input. The next part of a program typically is the processing. So, and you know, in many cases, right, it's often like doing the math. So I'm going to say do the math, right? And so we have to do the conversions now from millimeter to inches. And what are we actually being asked? It displays the dimension of a letter size sheet of paper in millimeters. So really what we need to do is convert the inches to millimeters. And if there's 25.4 millimeters per inch, couldn't I just simply multiply those two numbers together? So for example, 8.5 by 20 times 25.4, and that will give me the width, correct? Yeah, it will. All right. But there's a few different ways to do this. So here's how I'm going to kind of encourage you to think more like a programmer than you would instead of like just pulling out the calculator, which we will do, by the way, to verify our math. Because I could just go in here and do 25.4 times 8.5 equals That's the number we're looking for. And this seems goofy to do it manually when I can write code to do it. But the concept is, if I'm writing code, I want to confirm that the answer that it's giving me is correct. And this is, programmers often forget this, right? And I think this is a really critical piece, because you can't always count on the code being absolutely correct, right? Because there's ways that it can get flawed. So what we're going to do now is we're going to create a variable, and I'm going to call it width in millimeters. And this is kind of weird, because now you're going, hey, so why aren't you doing that in all caps? All right, so let's talk about that. A constant is assumed to never change. So we go all caps, underscores between words. Here, I'm assuming this is going to be a variable. Well, in this case, it really won't be, but in reality, if I was doing most computer programs, I don't know what numbers are going in, and I don't know what the answers are going to be. So the number or the answer can vary. So when I have variable naming structures, notice I start with a lowercase w, and then when I reach a logical word, I start with a capital letter, right? So those are capital letters. And because this kind of creates names that have little humps in the middle, like a camel, they call this camel casing, by the way, right? Start with a lowercase, logical words start with capital letters. Why? This is a convention, once again, that programmers use. Not a rule, it's a convention, right? Right. So let's get the math in here. So I could just hard code the number. So for example, I could go 25.4 times 8.5 and then print that out, and I would have the right answer. Right. It's not really how programming ideally works, right? Since I've already declared it as a thing, I can just say, well, I can take the millimeter, and you see I'm trying to invoke what we call autocorrect here, right? Start typing millimeter, and notice how eventually it'll pop up. And I can just click on this, by the way. I don't have to type the whole thing. This is okay to do, by the way. You don't have to type every single letter. If the autocomplete suggests it, you can just grab it, right? So millimeter per inch times the width. And notice how that came up also. And I'm just going to press enter. And yeah, it scrolled over to the last line, but they're really on the same line. I also know the answer for that should be what? 215.9. So I'm going to put it as a comment at the end of the line. And once again, it's scrolling off the edge, but that's okay. I'm just moving my divider over. So I know what the answer is already. I'm hard coding it. So when I do the output, I can confirm it. Then we're also going to do the length in and that's going to be really similar to this. In fact, I'm going to copy most of this. And this is the kind of clever stuff you guys have to start like identifying as you're coding, because really, you know, it's so close. Why retype the whole thing? I mean, seriously, right? All right, we should do that math too. So I'm going to bring up the calculator here, and then I'm going to say, we'll clear that wherever clear is, and it's 11 times 25.4, which is 279.4. I'm just adding it as a comment here. 279.4. I know the answers, so this is what I'm expecting to get on the screen. So this is the math. Is there any other math I need to do? I've made the conversions. Is there any math I need to do here? Nope. That's all of it. Last part of the program is going to be output. Or, you know, put the results on the screen. Okay. So here's kind of like one of my standard things about putting stuff on the screen. And okay, this partially comes from being a web designer, right? So like I always think about like, hey, what are you putting on the screen? What does it say? How does it look? Is it communicating? Right? Because what I could do is I could just print, for example, I could just do print, what is it? Width in millimeters. And I could also just print length in millimeters. And I'm going to run it right now just to show you that it works, right? And there's the answers. Kind of some interesting answers here, though. So let's talk about that for a second. This is not coming out to 0.9 the way it's supposed to. And welcome to the rounding errors of binary to base 10 number system conversions. This is known in Python. What astounds me about this is why Python has become the primary language for doing data science and artificial intelligence work when there's rounding errors in the math. And I know that any of you that are doing other languages, it's like, I don't see this in Java. Why is it happening in Python? Because Java's got stuff built into it that fixes it automatically. Python doesn't hide it from you. That's what the difference is. So I can identify that as a rounding error because of the conversion from binary to base 10. And really it's going base 10 to binary and then back to binary again, or back to base 10 again. All right, so we have to fix that rounding problem. That's one thing we have to do. The other one worked out fine. Why? Because the numeric conversions in the background worked with the base 10 to base 2 conversion. It worked. Right. However, if I run this program and I get this output, what the heck does that mean? It doesn't mean a darn thing, folks. So this is where you have to start getting verbose also with your output and telling your user, hey, this is what's going on, folks. So sometimes I will do goofy stuff like I'll start by printing a blank line. Why? Because this stuff will always be there. Wouldn't it look nicer if this was just pushed down one line? Yeah, it would. It's just goofy little stuff. The next thing I'm going to do is copy pasted, is I'm giving a verbose output to my users to let them know what they're looking at. So I'm putting in a line of text that says, a standard sheet of 8.5 by 11-inch paper has these dimensions. And then I'm going to output it in millimeters. You guys feel where I'm going with it? All right. So that part's good. All right, let's run it again. All right. That looks good. Moving it down the line looks good. That still looks bad. All right, so I have to like coerce my output statement. Now, first of all, I got to figure out how to round that first number. So here's how I'm going to do that. Inside the print statement, I'm going to use the round function. So I'm going to take the value of width in millimeters and wrap it with a set of parentheses. So really the function statement is this. There's a rounding command. So round parentheses inside there width in millimeters, but I also need to give it what we call a second parameter. So I'm adding a comma, which tells it how many decimal places am I rounding it to? The answer in this case is 1. I'm going to run it again just to show you that it works. Okay, there's the answer I'm looking for. So now the number looks good. Well, both the numbers look good, but I don't want it to say 215.9, 279.4. It's still kind of not verbose enough, right? So what I'm going to do is inside this print statement, I'm now going to add a comma and a space, and then some double quotes. Notice how it auto-completes. And I'm going to add for millimeters, space, X. So in other words, it's going to read 215.9 millimeters by X, right? And then I'm going to put in the other one. Now, the other number really doesn't need to be rounded, by the way. Does it? Not seemingly. And I think this is where it's a little weird. So I could do it like this. And I'm going to run it and show you it'll look fine. Oh, wait, there's something I should add to that too, right? I should do the same thing I did before and do that. All right, let's run it one more time. So a standard sheet of paper of whatever paper has these dimensions, 215.9 millimeters by 279.4. And this also explains to you why European paper is a different size than, in the US, right? Because the numbers aren't like pretty, they're not precise. So they have this other format called like A4 or something like that. I don't even know what the dimensions are.
I have a question on formatting, kind of related to this. I can't, if you want to put a period after the one of those dimensions, I can't figure out how to get it to not put a space there.
All right. Where is it you want the period to appear, George?
After 215.9.
You want a period right here?
Yeah.
You just put it right here. Okay, watch what happens though. It's not going to work exactly how you want. Okay, so here's kind of like this. Yeah, it's not the effect you're looking to achieve, right?
Right.
Yeah. What George is looking to achieve is he wants that period here, right? What's happening is in Python, these are concatenation symbols, right? And we haven't really gotten into this topic, but I'm about to do a little demo on it, by the way. And whenever you use that concatenation symbol, it will basically insert this extra space that I'm not declaring. This is different from most other languages, right? And there's an alternate way to concatenate this, by the way. And so I'm gonna do that approach. I'm not really a fan of kind of doing it at this juncture, but I'm gonna do it anyhow. So I'm gonna take the same statement.
Don't worry about it then. I'll work. I could wait. It just
No, actually, it's my next demo, George. So
okay.
yeah. So instead of using the comma, you can use what other languages use, which is the plus sign. Right. So this is the standard concatenation symbol in most languages. And guess what? Python also supports it. This is where it gets a little strange. Now, I want you to watch the output on this, right? Yeah, it doesn't like it at all, right? And there's a number of different reasons for it, right? And let's see what the trackback says here. Unsupported operand types for plus, float, and string. So it doesn't like combining these in this method because the concatenation symbol really is reserved for when we're only dealing with strings. That's kind of the answer. And so the workaround is that you store this value in a string and then output it as a string, and then you can concatenate it and put the period wherever you want.
I don't think I care about that very much if I got to do well.
Yeah, it's I agree. It's not one to care about a lot at this point. I will do a little demo on this though to show you the different methods. It's not super critical at this point. If you did this output, I would be quite happy with it. So let's call this a completed program, folks. Now, when it comes to screenshotting, so I'm just do a really super quick little demo of this because there were enough people kind of challenged by it. So all the exercises, screenshots in the same document, please, right? Label the exercises, so you might have a header and whatever, but you might call this exercise 2_1 or 2.1 actually is what it really is. And then I would come in here, I'd grab my snipping tool, being in Windows, right? If you're on the Mac, you use screenshot tool or the grab tool. I'm going to grab my code. Notice how tight I'm screenshotting it, right? copy, pasting it in to Word. There it is. Press enter to move down with the cursor. Back over to Spider and the snipping tool. And then I'm going to do a screenshot of the console output. Right, and that's the output right there. And copy that. And that also into Word. And then a couple of helpful tips, right? Once again, and I said this to my database class, some of you caught it when you were coming into the session early. Whenever you're doing screenshots, if the font in the screenshot is smaller than the font in the document, it's going to be really, really hard for me to see. Right. That's one of the reasons why I don't want you grabbing the whole darn screen. Right. Just grab the part we need to look at, all the code, and all the output. Right. Doesn't have to be perfect. Ideally, you would label it and, hey, this worked. Right. Yoo-hoo, or whatever. Or help, you know, and make it like, you know, bold and red and maybe highlight it and so I can notice, you know. But if that's happening, you really should be like shouting out now or emailing me or whatever, right? But we will write some code where you might struggle and you might not get it to work, or you might have had a lot of problems. I want to hear about the problems that you had and that you got it to work, you know, because it's part of the process. Trying the code and having it fail is as much part of the process as getting it to work. And often, and I know I've said this a few times, you learn more from the failures than you do from the successes.
So real quick, if the code fails on here, does it turn red or something, or how do you know the code failed?
Well, here's an example. So I just broke that statement.
Yeah.
And then this is like invalid syntax. It doesn't really tell me what, but it tells me where to look. Right. In other cases, and I'm just trying to think like here, if I did a print statement, okay, that's going to highlight. Notice it's also got a little red mark there. Okay. And then if I do try to run it, it'll try to run it, but it's going to point kind of where it thinks. See that little pointer there?
Yeah.
It's not really finding the right spot. The right spot is up here, but it's close. And usually wherever that pointer is, you go up in the code to find the problem.
Perfect.
Interestingly, you know, you can follow these pathways sometimes, you know, but if you have red marks here, it's not going to run here correctly, period.
Okay.
Phil, you have a question, I see.
I apologize if I missed something, Ty. When you look at line 18, the string line is length in millimeters. So that looks like there aren't any spaces in length in millimeters. So am I assuming that the capital letter is replacing the space?
Yeah, okay, so this is an important thing because we haven't talked about it, but the convention for, not the convention, but the rules, there are rules for naming variables. Variables cannot contain spaces in their names. Yeah, not at all, not allowed. Right. If you want to simulate a space, you can use an underscore or a dash. We do that with a constant naming, right? But here we use camel casing, so it makes it a little bit easier to identify the logical words if there's logical words in there. And what you name it, real frankly, matters too, right? You know, the modern convention is be verbose. Name your variable what it is containing, so you're not guessing. However, people don't always follow that convention. It also becomes really important to understand that whatever you name something, that name must be precise in order for your code to work. So for example, if I came up here and changed this to an S, which I should have, by the way, notice how these other two lines of code now are broken because these also need that change, right? So naming must be exact, upper lowercase. You cannot use Python keywords for a variable or a constant name. You cannot start with a number. And there's a couple special symbols you're not supposed to start with either. But generally, if it's not like highlighting like a reserve word like print is, it's okay to use. All right. We'll call this exercise complete. We should really move on to the next one. All right. So let me go back to the book temporarily here. And we're doing exercise 3, which is write a program that reads a number. And whenever we see this in the book, reads a number means the user is inputting it, by the way, and displays the square, cube, and fourth power. Use the star operator for the fourth power only. We haven't even talked about what that is yet. So we're going to talk about all of that. So I'm going back over to Spider here. New program, Control N, by the way. Save as, didn't burn me this time. And we're calling it exercise 2_3 and saving it. I'm going to grab the instructions from the book, copy pasting them here on my other screen, and then pasting them into my program. I'm also going to turn on the word wrap, and I'm trying to remember how to do that. And here you go to Tools, Preferences, Editor. Oh, I do have it turned on. Let's just apply it. Right. Oh, it is on, but I've got my screen wide. No wonder. Okay. So I am going to zoom in here a little bit. That looks pretty good right there. All right. So once again, we're going to follow some of the conventions that we've already learned, and I'm going to kind of add some new wrinkles here. Right. So the first thing is we are still going to get an input, but this time we're going to get a number from the user. That's what's going to happen first, and I'll label it input. So here's where we're going to learn to use the input function, by the way. What is it that we're going to get from the user? We're going to ask them for a number. Okay, so I'm going to create a variable called, I don't know, number. That's where we're going to store it. I'll put in an equal sign. And then normally when I'm getting input from the user, I would just use the input function like this with quotation marks. And then I'm going to say, please enter a number. Okay, but the reality is, by the way, that I don't want them to type like 42.5. I want them to enter an integer, right? So here is math speak, folks. And if you guys don't remember this, integers are counting numbers, right? And so because I assume nothing, right, I'm telling my user that what it is. Please enter an integer. What's an integer? Oh, counting, like 1, 2, 3. Yeah, okay, got it, right? So once again, be verbose with your users so they know what the heck you're talking about. And then I'm going to add a little bit to it to say to see its powers, meaning squared, cubed, and to the fourth power. And this is a prompt, by the way. And so I'm going to put in, I don't know, something that looks like a prompt. I'm going to use a colon this time. And then I'm putting a space at the end of it. Because if I don't, and in fact, here, I'll just go ahead and run this, let you see it, right? So if I click in here, look where the cursor is. If I add a space here and run it again, right, and this one has to be stopped. All right, let's run it again and take a look where the cursor is now. It's over a little bit. I think that looks better. I'm just saying, right? If you're wondering how to terminate a program while it's running, Control-C in the console. I'll repeat that many times, so don't worry about memorizing it now. All right, here's the other issue with this, though. I don't want them to just type a word, because as it sits right now, they could type a word, and I would think it's a number. I need to implicitly convert what they're typing at the screen. Remember, everything that's typed at the screen is text. We need to turn that into a number. So now I'm going to add this statement. This is straight out of the Kahoot, folks. And then I'm going to put another set of parentheses around it. And so it'll take whatever's generated by that input statement and convert it to an integer and then store it here. Okay. And let's do a really primitive test here. So I'm going to do print number. So I'm just going to run this and I'm going to type 5 and there it is. So it's capturing it and it's putting it back on the screen. So it's working. All right. I'm going to get rid of that print statement. So we have our input. Are there any other inputs to this program? Nope. That's the only input. We're just asking for one number and then the program does the rest. All right. So in the background, now we're going to do the processing steps. Remember, do the math, right? And we'll call that processing. If you want to label it, I think it's helpful sometimes. And so now I'm going to create variables that are going to hold the answers and then output the variables. And we're supposed to do the square. So I'm going to create a variable called square. Notice all lowercase. It's not a reserve word. That's fine. How do you get the square of a number? You multiply it by itself. It's the number times the number. That gives us the square. It is important to note, and I'm just going to say this, that there's another way to do the math, right? So if you read the chapter, you'll have learned that, this is for addition, this is for subtraction, this is divide, this is multiply, right? If you keep reading and hopefully latching onto it, you'll also notice that you can take a number and if I want to raise it to the second power, I use 2 asterisks in a row and put a 2 after it. So that's like saying the number squared. But if you notice the instructions, it says use that operator only for the 4th power, not for the other ones. So basically what I'm saying here is that an alternate way you could express this math really is by doing number ***2, right? But we're not going to use it. The cube, which is the way you say to the 3rd power, by the way, that's like geek speak, is the number times the number times the number. I want you to notice a couple things as I'm doing this. I generally, when I'm writing math equations in Python, I leave spaces between stuff. Why? I think it's easier to read. I think most programmers tend to agree. Could I do this instead? Could I get rid of those spaces? Sure. Still work. It's not a problem, right? The alternate version of this one, of course, would be number ***3 to the 3rd power. For the 4th power, and we'll just call it 4th, may the 4th be with you, right? We'll just go number ***4. Right. Of course, the alternate for that one would be, right? Not that we really have to put it in here, but since I'm doing it, may as well. Would be, those are all equivalent statements. Does it matter which one you use? Okay. Frankly, no, not at all, right? There might be some processing speed differences in the different versions, but I don't think there's much. So I wouldn't worry about it. All right. Next thing we have to do is let's display the results. Output, that's called. Right. So notice input, processing, output. And I will hammer that over and over and over again. One day it will stick in your brain after the 39th time. Maybe it's already stuck. Who knows? Yeah, we did. Yeah, Chris, we did mean to skip number 2. And thank you, Juan, for replying to that. I did get some people last time that did all the exercises, like from like 1 to 15. Hey, whatever. That's fine. It only builds character. I choose certain ones for certain reasons. All right. So the first thing I'm going to do once again, and this is me being goofy, right? This is, I would not say required, but I like to tell people what's going on. So I'm just putting a message up there. Notice blank line. Thank you for entering a number. Here are your results. Another blank line. And now I'm going to put the stuff on the screen, and I'm going to do this fairly efficiently. It's called copy paste. And I apologize, but I do have the answers already prepared. So one is going to say the square of your number is, right? And then notice, very simple. We finish off the statement, comma, the variable name, and that will display. And since we're going to do the cube and the fourth, we'll put those on the screen too. And I know you guys are scrambling to catch up. That's fine. There are those rare moments where I become kind and drop code in the chat. This is not one of them. Just remember that you can go back to the video. It'll be posted by tomorrow, and you can follow along if you can't keep up right now. If you're struggling to keep up, if I'm moving too fast, you know, the tip is, you know, watch the video, pause the video, take your time, type it in. Some people get clever too and just screenshot my screen, you know, and there it is, right? I'm not hiding the answers from you. This is more about the process of how it all works. The other thing is, and once again, this is me being like ridiculously geeky and overly user focused, you know, it's not a bad idea to tell people that the program's done running. Thank you, come again, you know, whatever it takes. Got a question there, Phil? I saw your hand go up, or did you hit it accidentally? All right, I'm going to go ahead and hit the run on this, folks.
Okay, I'm here. I'm okay. So Ty, I'm really trying hard to grasp what you're teaching here. So we went from hello world to what you're teaching now. So as far as what your recommendation is to catch up and be at pace as to what you're teaching right now, is that review the videos and the book?
Yeah, you're right, Phil, because generally as we move forward in the class, right, and it's okay that this is in the recording, is my lecture videos are already recorded, right? So if you watch those lecture videos, I will talk about these concepts and often demonstrate them. And then, so you watch those lecture videos, you read the chapter, which basically the lecture video follows the chapter for the most part. And then you give the exercises a try. And then when you come to class, we'll focus on the coding, and I will pepper in a large amount of lecture stuff in the coding as well as we're doing it, right? And I get that it might not click immediately, but that's kind of the beauty of the video too, is that you can rewind and go back and watch, and you can go back and refer to the book. And I know that the very first time you encounter a lot of this stuff, it feels like when you jump from one concept to the next, that it's jumping really quickly. And we are introducing a lot of different things here. So we're contending with math all of a sudden. We're doing conversions from strings to numbers. We're grabbing input from the user. We're learning how to name variables and constants and what those concepts even mean. Even the naming process is kind of a convention, and not all of it will resonate immediately, and that's okay, real frankly. What will happen ultimately is that they will come more into focus the more you do it and the more I repeat it, because a lot of this stuff will repeat. And this is exactly why we spend 2 weeks on this second chapter and not just one, right? Just for that reason. All right, folks, I'm going to call this complete, but we do need to test it, right? So we haven't tested it. I'm going to put in a really basic number. So I'll put in 2. 2 squared is 4. 2 to the third power is 8. 2 to the fourth power is 16. All right, and those, I just know those, right? But if the algorithm works with a simple number, like think back to that fertilizer thing, right? Once they know the formula, it should work with any number that I put in. So if I put in like a really ridiculously large number, yeah, and that might be a little bit shooting myself in the foot there. It will also process that. And I want you to notice how quickly it did that math. That's like crazy fast, right? And the other, so this is the other thing about Python and why we use it to do AI work and data science is I like refrain from putting in a really large number, but here I am putting one in and it still goes really, really fast, right? That is not a small number, you guys. Yeah, it's huge. I'm not even sure what it is. Right? I could figure it out, but let's not waste the time. Let's move on to the next exercise. We have 2 more to get through. All right, so the next one is exercise number 4. All right, so this one has a few steps to go through. And you'll notice it says, write a program that prompts the user for 2 integers and then prints the sum, the difference, the product, the average, the distance, the max, and the min. Okay. And they give you a little hint that Python has functions built for max and min, and we'll look at that. But there's several different things going on here. Now we're going to prompt the user twice. Well, we've already done this once, so shouldn't be too hard. In fact, we can borrow some of the code. And then we're going to do a bunch of different mathematical equations. So we're going to test all the different basic math functions, and then we're going to output it all to the screen. So this is a process. This is kind of multiple steps. So once again, I'm going to take those instructions and I'm going to copy them into Spider. I already have them copied. I'm going to make a new program. And I realize at this point that we're going to be moving fast. We got 15 minutes left. Right. So I still want to like lecture a few things, but it's still, we got a time limit. Here's the instructions for the program. Right. And I'm going to do a save as. No, you didn't burn me yet. This is exercise 2_4. All right. In our last program, we already asked the user for an input as a number, right? Well, we're going to do the same thing again. So I'm just going to borrow all that code. Why we reinvent the wheel? There's the code. Number from the user, right? Please enter an integer to see its powers. That part's not right, right? Please, what should we say? Please, why don't we just say, just please enter a counting number, and we'll just leave it at that. That's pretty good. All right. And then we need to do it again. We need to do it twice. So I'm going to copy this, and then I'm going to kind of talk a little bit about another issue here. Here I have this variable. Do I want to put them in the same variable name? No, I'm going to actually hotwire my code here a little bit. And I'm going to use kind of another little programming convention, by the way, which is I'm going to number these. So instead of going number and number 1 or number 2, I'm going to go num1 and num2. I think that's a really common programming thing. But I'm going to prompt them once, and then I'm going to prompt them again. And I'm going to tell you, and really this should say an integer. So there's my bad English there. But the second prompt is going to be slightly different, so I know it's a different one. Catch my drift, right? So please enter an integer. Please enter another integer. And in fact, on this one, hopefully they got the counting number part of it by now. So I'm not going to repeat that part. But 2 different inputs, 2 different things being stored. Once again, we're going to do a bunch of math. We can call that processing. Right. You don't have to put these comments in, but I find it's kind of interesting that how often this paradigm holds in programming. It's crazy. Right. It's really what we do the whole time. Input, process, output. Input, process, output. All right. So now we're going to do a bunch of different things. So now we want to create variables that are going to hold the math. And I'm going to do one called sum, and that one's orange. I can't use the word sum because apparently it's a keyword in Python. So I'm going to call it something else like sum of nums. sum of numbers. Yeah, I want to call it numbers, whatever, it doesn't matter. I'm gonna make it short. Okay, so what's the sum? Well, I'm adding num1 and num2. Those are being added. Then we're going to do a difference. I'll just call it diff. And then I'm going to say num1 minus num2. Could potentially yield a negative number. We're going to also do the product. The product is num1 times num2. And then we have, oh, here's one that comes back from the Kahoot. The average, right? How do we do an average? You add the numbers together and then divide by 2. But guess what? I already added them together. So I'm just take the sum of nums, right? And divide by 2. Or, and I'm just going to put this in a comment here at the end. The other way to do this, of course, is I could just say num1 plus num2 divide by 2. And if I leave it like that, the order of operations would do this math first, which we don't want. And so the other alternate would basically be to wrap the parentheses around that. But since we already did it, I can just drop that number in and it'll work just fine. See, these are the kind of clever little things that programmers notice, by the way. Then we have what we call the distance, which is the absolute value of one number minus the other. How far apart are they on the number line is really what we're asking. And there's actually a function for that. This was also in the Kahoot. So I'm just going to take the difference, whatever that difference was, and I'm going to get its absolute value, whether it's negative or positive, and it'll just give me the value without the sign. Then we also have the min and the max. And so I'm going to create variables. I can't call them min or max because see their keywords, they turn orange. So I'm going to call it, I don't know, my min equals, and then I'm going to say min is the two numbers. We'll just feed them in. So we say num1 comma num2. So if I add more numbers to determine, so for example, if I had a list of 10,000 numbers and I wanted to find the smallest one, I would drop them in here and it would find the smallest one for me without me looking. Right now we're only using 2 numbers. Oh well, but it still works, right? I also want to get the maximum. So I'm just going to change this to max and change this to max. All right, so there's all the math, folks. Those are all the equations. Next, of course, we're going to put the stuff on the screen. I'm going to create a bunch of blank lines here first. So we're going to display the output to the screen. Start with a blank line. I always like to do that. You don't have to, by the way. And then we're going to display everything. And in the interest of time efficiency, I am dumping this all on the screen at the same time. And I'm doing you guys the sort of solid. If you've been keeping up all along, I just saved you a whole bunch of typing on the print statements here so we can move on. All right, so you can grab it from the chat if you need to. I can't promise that's going to happen all the time. There is one difference here, though. Last time I named it with 1 F. This time I'm naming it with 2, so you guys need to make the same fix. I'm going to go ahead and give this a run. I'm going to scroll up in the console here, or scroll down, actually. All right, so we're going to enter an integer. All right, so I'm going to use really simple numbers so that we don't have to guess whether the math is right or not. Normally, I would test all of this, so I'm going to put in 5, and I'm going to put in 3. The sum is 8. The difference is 2. The product is 15. The average is 4. Yeah, totally. Right. It's right in between. The distance is 2. The smallest number is 3, and the biggest number is 5. So it is working. All right. When we work on the second set of exercises in chapter 2, by the way, we're going to take the same exact program and we're going to change the output to make it look really nice. Right? It'll look like it's all lined up and like we planned it that way, because we did. Right. One more exercise to go. I know we only have 5 minutes left here, so let's take a quick look. And with any luck, we can get this done. All right, so this one says, write a program that asks the users for the lengths of sides of a rectangle. Oh my God, it sounds like the fertilizer problem. Then print the area and perimeter of the rectangle and the length of the diagonal. There we go. There's some math. They weren't doing that with the fertilizer, were they? Right, so that's a little Pythagoras coming in to haunt us. All right, so I'm going to copy in the instructions in the spider here, but I am going to create a new program. Save as. And this is exercise 2_8. All right. I'm going to paste in the instructions at the top. Zooming in. Now, I know we are limited on time, but here's what I'm going to tell you. If you need to go whenever you need to, right? So I understand that thing. I'm going to code this all the way through, even if I go over time, because there are a couple of new concepts I'm going to throw in here that are pretty important. The one thing that we're going to start with, though, is kind of the same thing that we've been doing, because we are saying here the program that asks the users for the lengths of the side of a rectangle. Okay. So we're going to start with getting inputs. All right, so I'm just copy pasting that in. Now we're going to prompt the user for length, right? And this is not a great way to code, but sometimes, you know, I write my variable names first, and we're going to ask them for width, and we're going to ask them for input. So I'm going to type my input statement, and I'm going to just get the verbiage of it right first. So I'm going to say, enter the length of the rectangle. Okay. And you know what? The width is going to be really similar. So let's just copy paste it, and we'll just change a few letters here. There comes the width. Okay. We know from at least 3 iterations of me repeating it, basically that when we type stuff at the keyboard and we capture it, comes in as text. In the previous exercises, we've been converting the numbers to integers. But, and I'm just throwing it out there, who's to say that the user is going to input an integer here? Maybe the rectangle they're working with is 45.7 millimeters or inches or feet or yards or miles or whatever, right? So instead of converting to an integer, instead, we're going to convert to a floating point number. And the command for that is called float. This will give us greater precision and accuracy in the math that we're doing, especially when we calculate the diagonal, which may not work out to a nice round number. All right, so these are our 2 input statements. All right. It's late. I'm feeling kind of kind. There it is. It's lovely, don't you? for sure, cutting the code. All right. I'm doing that partially so that we can get to like some of the important concepts here, because once again, we're going to have the processing, which is, you know, do the math, right? And early on, this is largely what the processing is. And there's some things that we have to figure out. So the area and the perimeter, right? So area is a very simple formula, by the way. So I'm going to call a variable area, and I'm just simply going to take the length and multiply it by the width. That's the area. By the way, if you're not sure what the formulas are for this stuff, because the book doesn't say here's the formula for it, there's this thing called Google. Maybe you've heard of it, right? You saw area of a rectangle, and boom, there it is. The other nice thing about, like, they have all this like on-screen stuff now, I can like type in a number and, you know, it'll tell me what the answer is like on the fly. That's pretty cool, right? So you're never going to hunt for a formula for really common stuff ever, right? It's all out online. You can find it very easily. Okay, so that's the area. The other thing is the perimeter. And basically what the perimeter is when I take a rectangle, I'm going to see if I can draw this here, right? Oh, gosh, right? Here's a rectangle. And you count the length of one side, add the other side, add the other side, and add the other side. That's what a perimeter is, if you're not aware of that. And so how do we accomplish that? That's a little bit different formula, but basically, if you think about the rectangle, the two long sides are the same and the two short sides are the same. So I could say length plus width plus width, or I can get even more clever and realize that I can say 2 times length plus 2 times width. Now, some of you will be tempted, right, order of operations, to do this, right, to put your parentheses in like that. And then, can anybody tell me, is that necessary here?
It is not.
It is totally not, right? Because this calculation will happen first, then this calculation will happen second, and then they'll get added together, so we don't need the parentheses at all. Now, if you're not sure, and I will say this to new programmers, if you're not sure, put the parentheses on it, no harm done. If I did it all as a series of addition, that still works too. Length plus width is the same as 2 times length plus 2 times width. It's identical, right? Is there a preference? Not at all. All right, now the diagonal, this is where it gets weird. All right. So let's go to our friend Google here for a second. Instead of an area of a rectangle, diagonal of a rectangle. All right. Okay. Well, first of all, it doesn't have a quick formula for us, but oh my God. Do you remember this stuff from like geometry class when you learned the Pythagorean theorem and you learned like a squared plus b squared equals c squared, right? And here, you know, and then ultimately, if you want to solve for the diagonal, what ends up happening is you have to take the square root of the other two sides squared and added together. And oh my God, do they have a symbol in Python for doing square root? Yeah, Alex, you're shaking your head. Absolutely not. Right. And so this is, you know, I know you guys like, man, I didn't want to do math. That's okay. I'm guiding you here. But we can use this thing called the square root function. There is a function for square root, right? And so I'm going to type the formula first. So we're going to take the square root of the width squared plus the length squared. Okay. But to get this formula to work, and you guys probably aren't seeing it because of my little goofy toolbar, it's not identifying what this function is because it's not part of the native Python libraries. In other words, in order for me to use that math function, I have to import that function from the math library. So here, folks, we are doing our first import. This is a fairly simple one, but common to do. So here's the syntax for it. Notice I'm going to the very top of my code and I'm typing in this statement from math, meaning somewhere out there, there's a library file called math and it's got all the math functions in it. So from the math library, we are going to import the square root function. So now that's become available to us, and now the formula will work. So when you write more and more complex programs, it is not unusual to import libraries that have special functionality that you can use to ramp up your work. Right. And, you know, I mean, anybody that's done like any Java or C# or whatever, right? In Java, we also say import. In C# we say using. And there's different statements, but basically they're all the same thing. You're just pulling in resources that don't natively exist in the current, you know, situation, basically. Very, very normal in programming. There are some super powerful libraries out there, by the way, that people use for doing AI work. So a lot of the AI stuff that people are developing, it's already in pre-written libraries, and they're just taking what's already written and attaching to it. And often these libraries, sometimes we refer to them as APIs, right? And we'll talk about that nomenclature as well. API stands for Application Programming Interface. I don't need to know the mechanics of square root, but I just need to know how to apply it in the syntax. All right. All that's left is putting it on the screen, folks. We'll start with a blank print statement. And then here come my 3 output statements. So I'm going to output the area, the perimeter, and the diagonal. And then I want you to notice we're doing our first little bit of formatting here. And what I'll do for that, I'll put that last one in the chat just so you guys don't mess it up. But basically what this is going to do, because the diagonal might have multiple decimal places, we're rounding it to 2 decimal places. We'll talk about how this works a lot more next week, because we'll do a whole bunch of this next week. But for right now, just understand that it's going to take whatever math this does and round it to 2 decimal places. And really what this signifies is, when you see this nomenclature, I guess, is wherever that percent sign is here, that number is going to drop in. We're rounding to 2 floating point values. All right, here comes the run. And now we're going to type in some numbers. And let's come up with some numbers that are kind of make sense. Let's 20 and 15. So how do I know the math is correct? Ultimately, I'd pull out a calculator and do the math. For the square root, the diagonal, I would have to verify it. I would have to drop it probably into a spreadsheet to verify it. Or if your calculator has a square root button, and most of them do, if you type it incorrectly, you should be able to reason through it. Now, I use numbers that I knew would give me very nice, clean answers, but that's not necessarily always the case. So what if the user types in, I don't know, and see how it's scaling. All right, folks, those are all the solutions for the first part of the chapter 2 exercises. So I'm going to end this video